All right, this was a question from the kinetics chapter or the kinetics module, and it is definitely a harder question. Um, as indicated on the news item, if you can work everything but the harder questions, you're in good shape. But let me go ahead and work this out because a couple people had questions on it. This is one of those examples where we have several trials and we're trying to figure out what the rate law is. In other words, what is the order with respect to each of the reactants? What makes this harder is that there are 3 reactants instead of just 2. We did a lot with just 2 reactants in the practice problems. So in this one we have A, B, and C. So we have 3 reactants that we're trying to figure out what is the order with respect to. Let me color code them. Okay, all right. We start this just like we do it if there are only 2 reactants. We're trying to find 2 trials where only one thing is changing, and we'll figure out what the order is with respect to that one thing that's changing. So as I scan through the trials, it looks like B and C stay the same on trials 2 and 3. So I'm going to figure out what A is doing between trials 2 and 3. I'm going to go that direction because I see that is times 3. And so as I come over here from 5 to 15 is also times 3. Again, I picked those 2 trials because B and C stay the same, which means they're not contributing to the rate, to any change in the rate. Only A is. And so from this pattern, if the rate changes by 3 when the concentration changes by 3, that is first order in A. So what I'm doing is I am building that rate law. Rate equals K times A raised to something, B raised to something, and C raised to something. And I have figured out that A is raised to the first power. All right, now I'm going to figure out B. And in order to figure out B, I have to find 2 trials where B is changing, but A and C are staying the same. So I'm going to scan the trials, and I'm going to try to find 2 trials where A and C are staying the same. And it looks like A and C stay the same as I look at trials 1 and 3. So let me figure out what the rate is doing between trials 1 and 3. And you'll notice it's times 1. The rate is not changing when B, as I look at this, goes from 0.2 to 0.6 if I go in the up direction. B is times 3. What pattern is this? Well, if the rate doesn't change when the concentration changes, that's 0 order. That's our pattern of 0 order. So the rate law has B raised to the 0 order, because when the concentration of B changes and A and C stay the same, the rate doesn't change. So the rate law is independent of the concentration of B. Let me move this down here. So in my last one, I still have to figure out what the order is with respect to C. In my last one, let me clear some of this. The beautiful part of using this electronic device. All right. So I'm looking for 2 trials where A and B stay the same, but C changes. And I'm not seeing one easily. See, B stays the same here. Let me carry up a pen. B stays the same here, but A changes, and C stays the same. I'm not seeing 2 trials where A and B stay the same, but C changes. But remember, just a minute ago, we decided that the rate law was 0 order with respect to B, so the concentration of B doesn't matter. So all I have to do is find 2 trials where A stays the same, but C changes, and I can figure my rate law, my order of C. And so A stays the same here, while C changes. C is going up by 2, where A stays the same. So what is the rate doing? It's going up by 4. So what pattern is that? If the concentration goes up by 2 and the rate goes up by 4, that is 2 squared. And so the rate law has C raised to the second order. See, that's a much more difficult problem than our practice questions. And this one was flagged as an extra credit, and so I don't feel too bad about that. If you see one on the final, it will probably not have 3 reactants. In fact, I'll just go ahead and tell you. The final exam will have one of these, and it will not be 3 reactants. It will only be 2 reactants, back to the kind that we saw on the practice. The last step is to figure out what the rate constant K is, and I should be able to take any one of the 4 trials and calculate the rate constant, and I should get the same value. And I'll just plug into this rate law. And so let me take trial 1. The rate is 5 equals K times A is 0.2, and that's raised to the first power. B is 0.6, but it's going to be raised to the 0 power, which just makes it 1. I'm just going to leave it out. Times 0.1 for C squared. And then I'll solve for K. Plug that in my calculator. 5 divided by 0.1 squared divided by 0.2. And I get that K is equal to 2,500. And if I plugged in values for trial 2 or 3 or 4, I should get exactly the same value.